distance at uniform speed. If the train had been 10 km/h faster, then it would have taken 1 hour less than the scheduled time. If the train speed was further incremented by 10, it would have taken further 45 minutes less than the scheduled time. So the length of the journey is what? This is quite similar to the previous question that we had studied, okay? So a train covered a certain distance at uniform speed. This speed is not given. So let's consider it to be as x. Alright? If the train had been 10 km/h faster, let's write this question pictorially. Alright? The train is there, it is going from one station, it's covering some certain distance d that we don't know, fine. If it is covering, it's covering at a uniform speed x. If it is going to cover at speed x, it's going to take t to cover the distance. If the train had been 10 km/h faster, which simply means had it been x plus 10, then it would have taken 1 hour less than the scheduled time. So suppose if the train was to arrive at 10 a.m., it had arrived 1 hour less, which means it had arrived at 9 a.m. itself. Alright, so what am I supposed to do? It's t minus 1. Right? Makes sense? So third statement. If the train speed was further incremented by 10, which means it had already been increased by 10, and it is further incremented by 10, so it will be x plus 20. Alright? It would have taken further is what? With respect to the previous statement, it would have taken further 45 minutes less than the scheduled time. So further 45 minutes less is t minus 1 minus 45 by 60, because it is given in minutes. You have to convert it into hours, alright? So let's write this. T minus 1 minus what? 3 by 4. So this can be written as t minus 7 by 4. Right? Okay? Alright, fine. So now, so this can be written as t minus 7 by 4. So in the previous question, right, we had actually saw that both of these instances, both of these statements are given for early. For early, what is the equation? T original minus t new dash is equal to the amount of time it had arrived early. Right? I hope you guys remember it. So we know that speed is equal to distance by time, and time is nothing but distance by speed. So time original is what? This is t original. And here you know both of the instances are given for early only. So this is also one t new dash, this is another t new dash. Alright, so what is the first equation? D divided by x minus d divided by x plus 10 is equal to how much hours did it arrive early by? It arrived by 1 hour early, right? So this is going to be our first equation. So for this statement, the third statement, the equation shall be what? It's again arriving early, alright? It would have taken further 45 minutes less than the scheduled time, which means it's again early, alright? So it is d by x minus d divided by what? X plus 20 is equal to what? How much hours did it arrive early by? 7 by 4. Alright? Yes. So this is going to be our second equation. So we have to simplify both of these equations. So how do I do that? So let's try to simplify the first equation, alright? So let's take d common off. It is 1 by x minus 1 divided by x plus 10 is equal to 1. So x plus 10 minus x divided by x into x plus 10 is equal to 1. Alright? So x gets cancelled. 10d is equal to x into x plus 10. Okay, so let this be equation number 3. Fine. So, simplifying equation number 2. So, what do you get? Equation number 2 is d into 1 by x minus 1 by x plus 20 is equal to 7 by 4. So, x plus 20 minus x divided by x into x plus 20 is equal to 7 by 4. So x gets cancelled off. And what do you have? 80d is equal to 7 into x plus 20. Right? So this is our equation number 4. Alright? Is it clear so far? So now, this 80d, how can I write it as? 8 into 10d. So from equation 3, we know what 10d is. What is 10d? It is nothing but x into x plus 10. So 8 into 10d, I am replacing this by equation number 3. So I will get 8 into x plus 10. This is nothing but equivalent to what? 7x plus 4. X gets cancelled. So 8x plus 80 is equal to 7x plus 20. 8 x plus 20. 7x plus 140. Alright? Yes. So x is equal to 140 minus 80, which is nothing but 60 kilometers. Alright? X is nothing but speed. So 60 kilometers per hour. Fine. So this is our x. But what should we find? The length of the journey. So how do I calculate the length of the journey? We know that 10d is equal to x into x plus 10. Alright. We have calculated x as well. So 10d is equal to what? 60 into 70. So 10d is equal to 60 into 70. We get it from equation 3. Substituting the value of x in equation number 3, what do you get? 10 times d is equal to x into x plus 10. X into x plus 10. We have calculated that x is nothing but 60. So it is 60 into 70 d by 10. So your answer is 420 kilometers. So I hope it was clear so far. Let's go to the next type of question in the next module. So far we saw instances like this. There was a constant distance and originally a person was traveling at a speed of x and t. But then it was like, okay, the person has incremented his speed by 10 or whatever, and so his time period has reduced drastically by 2 hours or so. Or if at all he is going to reduce his speed by 20, and then his time was also, it got incremented by 4 or something like that. We saw questions of this pattern, alright, and we went through a formula. If at all the 4 variables were actually given, we went through cases like this. But the point here, if you notice, is that the original speed was either incremented or decremented. This is an incremental situation, this is a decremental situation, right? But there can be another kind of question that could possibly come. One is that, so if at all his original speed was x and he took time t to cover the distance t, alright? So if at all he had reduced or incremented his speed, but if he moved with the speed of a by b of his original speed, this is what? Multiplicative of that speed. If he had moved a by b times his original speed, then his time period had incremented or decremented by some amount. Alright, so in cases like this, right, they would mostly ask you to find the original time in which he actually reached his destination. That is, it is very simple, okay? It is actually one particular formula only. So in cases like this, right, delta t can be written as what? T by a minus 1 into t. So this is a formula that can be used in situations like this. Alright, so if his original speed is x and if he can cover the distance d in time t, then if at all his original speed is multiplicative by something of the form a by b, and because of which his time has incremented or decremented by some delta t component, then the formula is this. Delta t is equal to b by a minus 1 into t. That is the reciprocate of the multiplicative of the speed. Alright, I hope it's clear. Let's understand a question, let's do a question so that we can, understand it in a better manner. Let's consider this question. Walking 6/7 of his usual speed, a man is 12 minutes too late. The usual time taken by him to cover that distance is what? Is a question. Okay? So, what do you know? If it's a constant distance d problem, if he is going to originally take x comma t, and if he is going to make his speed some a by b times x, then his time can be incremented or decremented by t. And we know that delta t can be written as what? B by a minus 1 into t. So, now look at the question. What is given? walking 6 by 7 of his usual speed. They have not given what his usual speed is. So usual speed is x. So in this case, what is a by b times x? They have given it to be a 6 by 7 times x. So this is his speed now. Walking this 6 by 7 of his usual speed, a man is 12 minutes too late. So his time period is going to increase because he is late, right? So it's going to increase. 12 minutes too late. Alright? So 12 by 12 minutes too late. Fine. So usual time taken by him to cover that distance is what is the question. So what amount is given? Delta t is given. Delta t is 12. Okay? And we know that a by b is actually 6 by 7. So obviously b by a is equal to what? 7 by 6. Apply this formula. Delta t is equal to b by a minus 1 into t. So delta t is 12 is equal to b by a 7 by 6 minus 1 into t. And we want what? The time taken, exactly this t only. Okay, so 12 is equal to 7 minus 6 by 6, the whole into t. So which is nothing but 1 by 6, 12 into t. So t is equal to 12 into 6. So time taken is equal to 12 into 6, which is nothing but what? 72. So this simply means the time taken by him to cover that distance is 72. 72 is nothing but what? 72 divided by 60, which is nothing but, it simply means he's going to take 1 hour, 12 minutes to cover this distance of t. So that is going to be our answer. See, it looks so simple just because you know this formula, right? So try out a few more questions, practice a lot so that you can think more prominently given a question. Right? See you next time.